Welcome to the second installment in Data Skeptic pilot season. We're trying out a couple new show formats, or topics really. Data Skeptic consensus is pretty much at an end and we're deciding what comes next. Last week you might have heard the first entry, Data Skeptic Conspiracy. Today I'm going to present Data Skeptic Social Networks. After we do a few more of these, I'm going to ask everyone to vote. Which topic do you think is best suited for our next season? Let's get into the show. Hey friends, welcome to Data Skeptic Social Networks, the podcast that's all about nodes, edges, networks, graph algorithms, and the dynamics of the mathematics that describe humans' interconnectedness. Today on the show, I speak with Mayank Kejriwal about knowledge graphs, both in theory and in practice, his experience conducting research on systems like Twitter, and writing a textbook on the subject.
Hi, I'm Mayank Kejriwal, and I am a research professor at the University of Southern California and also a researcher at the Information Sciences Institute, which is affiliated with the University of Southern California.
What areas does your research cover?
That's a great question. I would say it falls within applied artificial intelligence, but more recently I have also started working a lot on computational social science, especially analysis of Twitter and Gallup data from COVID-19 and so on. So there's always a strong computational element in what I do. And I would say it's 75% applied AI and 25% computational methods for understanding complex systems.
So I think it's fair to describe Twitter as a complex system. There's certainly lots of layers of interaction, people using it different ways. I've seen some servers that broadcast when they're having problems, and then, of course, politicians broadcasting. So lots of activity going on, which usually looks like noise in the data. How do you make sense of all of that?
Yeah, it takes a lot of data processing, and for example, one of the studies that we're very close to publishing it, it's going through a revision right now, but hopefully we will see it in the summer, is how people use emojis on Twitter. That's one of the things that we were very interested in. And so in order to get good data, we used the Twitter fire hose. So the Twitter fire hose, which I think is also called the Decker hose more recently, is basically 10% of all of Twitter. It has to be purchased. And so we had purchased it in 2016 to 17. So it's been a while, but it's like 50 million tweets per day, right? Because Twitter has approximately 500 million tweets globally in that period. I don't believe it's changed a lot. So for 50 million tweets per day spread out all over the world, there's a significant fraction, I would say about 2%, which doesn't sound like a lot, but it's still pretty big when you think about the number of tweets that have geotags. So these are people who have kept their GPS on, so we know where they are tweeting from. And we also know the language and, other kinds of things that the metadata provides, and we can extract the emojis. And so when we kind of combine all of that together, we are able to get a very strong sense, for example, that, people who are tweeting in English in, let's say, the US versus the UK, what is the difference? Or, Spanish in the US versus Spanish in Mexico. How do they use emojis? What differences do we see? And are emojis really universal, or does it really depend on where you're from and what language you speak and so on? So it's fascinating. That is what I would call a study where we use statistics and, very careful data processing to make sure that the results are fairly reliable. A second project that I will briefly mention that we are, just starting on right now has to do with studying natural disasters and terrorist events. So for that, one of my students has collected a lot of data, from external sources, that when the disaster happened, what was the disaster? Did we know about it in advance, or did it strike very suddenly, like an earthquake, unannounced, or like a terrorist event? And then since we know the time, the place, and the hashtags that we use to describe the disaster, we can do a fairly good data processing where we can isolate the tweets that are relevant and even remove some of the bot tweets and the spam tweets, and then kind of figure out that, okay, how do people tweet before, during, and after the disaster? And this is something we are just starting to do. So we don't know the answer, but I can't wait to find out. So it's just fascinating, the kinds of questions that can be answered once you have a lot of data that you can work with, and you have, specific questions that you can work with.
Yeah, absolutely. In your emoji analysis, did you uncover any cultural differences? Do people use them in slightly different patterns, or is it a universal phenomenon?
Oh, yeah. I think they are more alike than different, so I think that is kind of expected. But we do find that some emojis are extremely popular than others, like the smiley face emoji and the heart emoji. Those emojis tend to be popular, but we still see differences. For example, in Brazil, compared to the US, we find that the heart emoji is used very often, but in comparison to the smiley face. We also find that there are some countries and some languages that have very distinctive emoji profiles. So, for example, we find that for Arabic, the tweets that are in Arabic, the emoji profile, the distribution tends to be different than from several other countries. That to me suggests that it's not completely universal, that there is a degree of universality, but also that, different cultures and different regions have sort of used emojis and that are more specific to their local context. And so it could very well be that if you go from this country to that country, you would start seeing a difference in how people use the emojis and even interpret the emojis. So the data is definitely showing that.
When you look at then, I assume you're able to generate time series in some sense, look at the ebb and flow of emotional aggregates over time. Does that correlate with any ground truth? On a day that a cultural icon like a famous scientist passes away, can you see the sorrow and the grief in the signals?
We didn't do that study specifically, but I know from other literature that that's true. That you do see a trending theme, if you will, that shows up both in hashtags as well as in emojis. I think it shows up more in hashtags than in emojis, but I'm confident that if we looked at the sentiment, of the emoji, we would see that show up when a scientist or someone else passes away who is very well beloved. And I also think that, we see some, like over time, we kind of see that the patterns emerge very quickly in how emojis are used. If you study a day's worth of data versus a month's worth of data, and we did the comparison, the pattern emerges very quickly. So there's something fractal about the way that emojis are used on social media, that within a single day, if you plot the popularity of emojis, basically you count the number of tweets in which an emoji occurs and then plot a distribution. You do it over a day versus, let's say, a month. And you find that actually the scaling pattern is the same, which was really fascinating, which means that, it just whatever people are doing, within a day, the behavior has emerged, and so you don't have to wait for a long period of time before you start seeing the patterns. So there's something very fractal in emoji usage. And this might be true for other things also, like the way that people use words or hashtags. But at least in the emoji study, we were able to verify that there is a fractal behavior that is going on. So that to us was really eye-opening.
Do you think we should read into that? Is that some interesting property of the whole network or just the way it works out?
It's an interesting property of human behavior. What we see is that, human behavior replicates itself at different scales independently. And there are probably underlying fundamental laws that are governing that. For example, from my work in network science, there's this thing called preferential attachment, which is very famous in the network science community. It was proposed many decades ago by some very famous network scientists. And it's a very simple intuition. What it says is how networks grow. So, for example, when you join let's say a social network, or when you set up a web page on the internet, the question is that who do you link to, right? And who links to you? So maybe it's easier to understand in the web context. Let's imagine that you are publishing a web page on the internet and you are trying to link to other web pages, right? Because you want to be connected on the internet. And eventually you hope many people will link to you also, right? And that's what drives up your page rank and so on. Now, it turns out that you will probably link to the pages that other people are also linking very heavily to. And this is why we call it preferential attachment. You have a preference towards the entities that already have a large number of links. So for example, I will probably link to Wikipedia. If I want to explain something, I will link to Wikipedia. It will probably not link to some web page that is more obscure, right? Or something like that. And so it's kind of, many people are already linking to Wikipedia. Similarly, what we see is in a social network, when a new person comes in, they tend to gravitate towards people who already have a lot of friends. And so this, is kind of like the high school phenomenon that you want to hang out with the popular kids. I mean, that's the preference. And it turns out that that model, when you formalize it and then you evolve the network, you start with a few nodes and links and then new nodes come in, right? And then the network grows. And then that network, when you study its properties, are very similar to real social networks. And so it seems like there are some fundamental phenomena, some fundamental laws, whether it's preferential attachment or other laws, some of them are more controversial also. But it looks like human behavior, as complex as it is, can kind of be traced back to certain sociological laws. And I think that in all these systems, social media, social networks, etc., even in the offline world, we kind of see those laws play out at different scales. And so that's why we see this fractal behavior, because there's a fractal element to those laws.
Well, there's a great pantheon of good examples of network analysis. You've mentioned a couple, social networks and things like that. Where does the advent of COVID-19 and contact tracing and these sorts of analysis now fall in that spectrum of go-to example cases?
Yeah, so for that, I would say, we don't have access to a network where we can actually do the contact tracing, or I'm not sure anyone really does, to be honest. So for the COVID-19, we did not use network analysis. We tended to use more traditional methods where we had access to a lot of Gallup data. And, we tried to ask the question, some of the questions we asked were that what was the impact of these different restriction policies, for example, school closures or contact tracing, testing policies, are tests available in your area? So this was like, last summer. So testing was a very big thing. It wasn't available everywhere, right? And so we wanted to know how that impacted people's happiness levels. So we call that well-being, subjective well-being, where in the survey they actually ask you that yesterday, did you feel lonely? Did you feel anxious? Did you feel depressed? Did you feel happy? So they ask you these questions, and Gallup is very well known for that survey. And we can use that to measure people's happiness levels. So whenever you've seen a study like, that Denmark is the happiest country, or, those kinds of studies, it's based on that data, or data that is kind of like that. It might be a different survey, but same methodology. And so we have access to that data from last year, and, we will probably be getting another round of data this year. But at least from the data last year, we did the study, and we found that contact tracing, interestingly enough, did not please people who are working in government and public policy. So when they polled a lot of individuals, they found that, social workers were very wary of contact tracing. People who worked in government and public policy, interestingly enough, were very wary of contact tracing. Other professions didn't care that much, it turned out. We also found the usual things, for construction and retail workers, the workplace closing, led to a decline in well-being, right? Because they were probably out of a job is what it meant. And that reflected in the well-being levels. For finance, law, the white-collar professions, it didn't matter that much. We couldn't see any significant impact on well-being from these policy measures. School closing was very controversial. We found that overwhelmingly it led to a negative well-being, which means that parents really want the schools to open, despite the fact that it might be very controversial, and so on and so forth. So, we're still teasing apart these findings, and we're trying to put them through the peer review process so that if we did go wrong somewhere, the reviewers would point that out, so we wouldn't irresponsibly put this out there. We are doing those studies. They are less based on network science and more based on traditional computational social science, which would be survey data, getting large amounts of survey data. In one other case, we also use social media, where we tried to track on Twitter. We collected data over a week-long period before the election and after the election to try and figure out the causes and extent of vaccine hesitancy. So are we seeing on Twitter why people are vaccine hesitant? And to what extent are those causes dominant on social media, and have they changed from before the election to after the election? And the answer to all of that is yes. We're going to try and put it out there, but we are seeing very big changes from before the election to after the election. And we are seeing some very interesting and very diverse set of reasons for why people are vaccine hesitant. Some of which are based on legitimate concerns, others of which are much more extreme, things like COVID is a hoax or something like that. So we're seeing the entire spectrum, which is very interesting because it's not clear what is misinformation and what is not misinformation, because sometimes people are genuinely concerned and they're not putting misinformation out there, but they're just expressing their concern. So whether we agree with it or not, we can argue that is not misinformation. It's just someone saying that, hey, I read about this and I'm concerned. I think it's an interesting time that we are in, where we are trying to define what we mean by misinformation and what should be out there and what shouldn't be out there. So it's a very interesting time to be doing those studies.
I'm sure that the changes you're observing, it's a complex and diverse set of perspectives, but are there any major themes, any, consensus we can describe, or, 40% of the people are thinking this, or is it truly diverse?
So let me tell you a couple of really good conclusions that are just fresh in my mind. So the one thing that I would be happy to point out is that we saw that when we studied the hashtags and the keywords before the election and more recently, just 2 or 3 weeks ago, so not directly after the election, but right now after all the aftermath, the riots and all those things, the election fraud, supposed election fraud, all of that was getting discussed a lot right after the election. By now, it's calmer, right? We're in a calmer phase right now. That's why we chose to wait till all of that had become calm, and in order to really tease apart the vaccine-related data. So we did the study between the 1 week before the election and the 1 week just now, and we found that, unsurprisingly, Trump was number one before the election, trending number one. But right now, number one is Pfizer. So what I like to tell my press officers that it seems like Pfizer won the election because Trump was number one and now, Pedro is number one on Twitter. Interestingly, AstraZeneca, is continuing to face wars, right? We saw in the news that, some countries have paused vaccination for AstraZeneca because of complications. This was before we collected our data. But even in our data, we were seeing that, Pfizer and Johnson were certainly trending much higher on Twitter than AstraZeneca. So, I don't know whether that really counts for anything, but it's an interesting trend that we saw. Another thing that we found, which gave me a lot of concern, in fact, enough concern that I put it out there, which is based on both Gallup survey data as well as the Census Bureau. So it didn't involve social media, but it was Census Bureau and Gallup survey, where we found that there is a very high correlation and very significant correlation between loneliness and food insecurity in the 15 cities, the 15 biggest metropolitan areas in the US, when we did a correlation by tying together Census Bureau data that measured whether people were having trouble with food expenses versus, the well-being data that we have from Gallup. We found that there's an extremely high correlation between loneliness and food insecurity. So I think that kind of suggests, as other people have pointed out in, traditional social science, there's a stigma around food welfare, despite the fact that there are so many people, even in the US, that are actually food insecure. It could be as high as 10 to 20%, if not higher, as shocking as that might be. And the reason why we don't hear enough about this is because I think it's a source of shame for many people, which is very sad, I think. And, so when I found this, I was like, look, people are suffering alone. And if there's ever a time where we can have a conversation on this, it's now. Because right now, you see in the lines, there are mile-long lines outside food pantries. It was one of the images that defined the pandemic, where you had these long parking lot lines and, they shot the satellite picture and it became a defining image, right? And I was like, look, people are really suffering and there are many people who are suffering. So this is the time when we need to maybe start having a conversation around food deserts, food insecurity. So people are starting to have conversations, but I just fear that we're just going to go back to business as usual once the pandemic is over. But the pandemic has just exacerbated and made those problems more visible. I think that to a large extent, those problems were already there even before the pandemic, the food insecurity problems and other problems. But the data was really striking that there's such a strong and positive correlation between loneliness in particular, not the other well-being emotions, but it's specifically loneliness and food insecurity. The correlation was very high. So it's kind of interesting. Those are the two things that stand out. There are a few other things that are coming out, where we are investigating. For example, we did the study also based on income. We looked at how, if you belong to the lower income, middle income, which would be middle class, or upper income, how does that affect your well-being with respect to the policies like school closures and workplace closing and so on. What we found was that the lower income tends to react in the opposite way compared to the middle income and the high income. So the lower income, the middle and the high income would not, let's say, be worried about a certain policy. The lower income would be very worried. And so we would see this opposite correlation that was significant. And to me, this also is very telling because we know there is a lot of income inequality and a lot of division and polarization in the country right now. And, the data is kind of showing that in a very real way that, look, when you look at the lower incomes, they really are struggling a lot. And so, it shows up also in their emotional well-being and how they react to policies and how did the policies impact them. And there's a disproportionate impact. And we see the opposite trend compared to the other two. All of those things are, we're still teasing it, but, it's fairly consistent. I think some of these, the ones that I just pointed out are very consistent. Like, you sort of see them, they just glare out at you. You look at the data and that's the first thing that catches your eye. And then there are the, little, areas of complexity where you do see a lot of diversity and we have to tease it out. You might see a reaction in a certain job sector, but not in another job sector. You might see, in some cases, Republicans and Democrats agree. In other cases, they don't agree. But in all those cases, I have not seen cases where the Democrat is completely opposite to the Republican. So that is not showing up in the data. So we see that there are many cases where they are aligned, such as on school closures. But, the division that we are seeing tend to show up more with respect to what your income is and what your employment sector is. So, those kinds of things, which are not getting the press that they deserve. We keep talking about politics all the time, but real people have very real problems. They have far bigger problems than, I care about this issue and he doesn't care about this issue. And so, we're diametrically opposed and we should go to war against each other, just like the media suggests. But real people have very real issues, and that is where the difference comes in. And we're still trying to piece together a story. These findings, what do they really tell us? I don't think that's a very simple story to tell, but it's really a story about society. It's a story about people. And so it's complex for that reason.
Thanks to this week's sponsor, NordPass. NordPass is a password manager. You can use it to store all of your passwords in one place, to generate secure passwords and to share them securely. You need a unique, strong password everywhere you log in. And you need a tool like NordPass to keep track of that. In a given day, I log into a dozen services probably. In a month, maybe 100. NordPass makes it possible to manage all that safely and securely. NordPass is going to make your life a lot easier and keep you safe online. And if you're really curious, I encourage you to do some research on their zero-knowledge architecture. It's a very clever infrastructure that helps keep your private information private. Create one very secure login and use that to unlock all of your other logins. It's the pattern security professionals and data scientists like myself use on a daily basis. For a limited time, Data Skeptic listeners can get 1 year of NordPass Premium with plans up to 50% off. Visit nordpass.com/data. That's Nord, N-O-R-D, pass, pass.com/data. Well, I'm curious about the telling of that story then. For certain, there should be politicians on both sides of the aisle looking at research like yours and trying to understand it and have an impact. You say we're talking about politics all the time. In my opinion, you and I have not talked about politics yet. In fact, you haven't come with an agenda that you've set out. You haven't told me to vote one way or the other or endorsed a policy. But selection of choices like that should be informed by work like yours. Where do you draw the line? At some point, maybe you do want to have an opinion that your research suggests vote yay or nay on something, or maybe it's simply these are the statement of facts. Where do you align between informative and commentary?
Well, I would say we are pretty much in the factual camp and, we try not to go into the commentary camp because we're scientists, so I just feel that it's important for us to just keep being scientists while still exercising our personal views, in the voting booth or where we have to make choices like that, right? But, or, even institutionally, when we have to make choices that, okay, should I vote on this policy? Should I favor diversity, equity, and inclusion in my institution? And I am very much in favor of that. And I try to do what I can for that. So that you might argue is, less informative and more commentary driven because it's guided by certain preferences and views that I have, right? And so I can choose, not to be involved at all if I don't agree, right? Or to be involved if I do agree. And so I'm much more of a social liberal in those kinds of domains where I'm like, we should have more equality and we should have more, amplification of voices that have historically been suppressed. And we should tell the story. Now, that being said, I also feel that by telling the story in a very factual way, where we are not being normative, but we're just saying, look, this is what we're doing. Here's the data. We didn't come in with prior questions about, whether you should vote Republican or Democrat, but we are going to look at income and job sector. And we're also going to show you Republican and Democrat, but it's just one result out of many. And we try to make sure that all the results that we generate them in several different ways. So we call them robustness checks. So when we run a regression, we make sure we have several sets of variables. We report the significance levels very thoroughly. We map against not just one subjective well-being variable, but multiple variables, so that we can see whether there are some variables where the story might be more nuanced or even goes in the reverse direction compared to the other variables. But as we're writing this out, and then we want to send it for peer review, and then make sure that the reviewers agree with what we are saying, or if they don't, then they can tell us what their criticism is, so we can address that. I think that our job is, as scientists, is to kind of address an important question, but then show what the data says and what the limits of the data are, and then kind of leave it to the people who are being elected to look at the data and to not be in denial about it. And the best that we can do is to say that, look, we are just giving you very good results. These are very rigorous. We are not oversimplifying. We are not picking and choosing. We are accepting that there are going to be some results that are very ambiguous. If you want, you can pick those up and discredit the interpretation, or, you can maybe choose whatever interpretation you want by looking at the ambiguous data, and that would be your choice. As scientists, we just can't be black and white. We can't give you data that fully supports your views or the other person's views. The truth is that some of it will support these views and some of it will be more ambiguous. And some others can be interpreted in whatever direction you choose to interpret it. So in general, my work is not that political. I would also say that, with the exception of maybe this COVID work, where we have explicitly looked at things like income and political affiliation, almost the vast majority of the work that I've done, has tended to be social but apolitical, in the sense that, for example, I've done work in networks that describe the Panama Papers, which is dark money flows, right? And networks that describe human trafficking and online sex trafficking, those kinds of things. Those are very social. They're also very charged issues in their own way. And so we don't go into policy in those either, although sometimes I will go into commentary on that by suggesting that, look, this is something that is being stigmatized and it really shouldn't be. We need to study this more, but it still tends to be apolitical. So I'm actually happy about that. This is not my choice in a way. It's just that what I do has just naturally tended to be apolitical. And given how divided the country is, I think it's a blessing in disguise in a way that it is apolitical.
Well, to do good analysis in areas like this, you need a good collection of tools. One good source to learn about some of those techniques would be your new book, Knowledge Graphs, Fundamentals, Techniques, and Applications. Tell me a little bit about the general synopsis.
I don't know how familiar people are with knowledge graphs, so I'll just begin with that. So the story I like to tell is that imagine right now, suppose you type places to visit in Los Angeles in the Google search engine. And, we don't need to even type it because we can almost see it in our mind's eye what would happen, which is that you would literally see the places to visit. You wouldn't even have to click anything, right? Like Google would show you the images with the places to visit and you can scroll over them. If you type Leonardo da Vinci, you would not even need to click on anything because in the side, Google will show you a panel, what we call a knowledge panel of Leonardo da Vinci, and then you would see, what the other things that people have searched for, like maybe Picasso or Newton, and so on and so forth. For the places to visit in Los Angeles, Google will probably show you the hotels that are available, the flights, what the average cost is. All of that shows up on the site and is coming from internal data. So the question is that how are they able to do that? Because 10 years ago, that's not what would have happened. If you would have typed it, you would have seen a list of web pages. But you would not have seen the places to visit literally show up as if the engine is understanding your intent. So a knowledge graph is a way for a search engine or for any computational system, whether it's an algorithm, an AI, whatever it is, to understand that you are not just talking about strings, but that there are entities and relations and classes of entities in your query. And, that is kind of the easiest way to understand it, that the Google search engine is able to understand through the Google knowledge graph that the places to visit is a class of entities. It's a set of entities, which are tourist spots in Los Angeles. And Los Angeles itself is an entity. It's a city, right? And so simply put, a knowledge graph is a graph where the nodes are entities and also attributes of entities, and there are relations between the entities. So you have Los Angeles, and then that is in California. And then California is a state in the United States, and California may have a GDP, and California may have an unemployment number, and then California has this and that. And so, when you look at all of that information, that's a knowledge graph. Now, the knowledge graph could be encyclopedic, like the Google Knowledge Graph, or Wikidata, which is a publicly available knowledge graph that has been, in the Wikimedia Foundation, just like Wikipedia. And you can also have domain-specific knowledge graphs, which are for specific applications. For example, Amazon has an Amazon product graph that is very specific to e-commerce, obviously. If you do a different domain, you might see a different kind of set of entities and objects and, relations. So the knowledge graph is, simply put, it allows a machine to know, because you are, instead of just giving it, lots of strings and documents, you're allowing it to think about the world, about the domain, as a collection of entities that are linked to one another. And that's why it's a graph also, right? So the knowledge is coming from the entities and the relations, and the graph is because it's represented as a graph. There are many questions around this model, right? So how do we get the knowledge graph? Where does it come from? And the answer is usually it is extracted from text, right? And so you have to apply NLP and all kinds of really difficult AI tools, and in order to extract the entities and extract the relations and then clean it up and so on. So that kind of, how do you construct the knowledge graph? And that is one entire section of the book. The other section is that when you extract the knowledge graph from lots of text, the same entity might show up in many different guises. So you have Donald Trump and President Trump and Donald Trump Jr. and so on. And, it's not just that they look similar. Some of them are very different. They refer to different people. In some cases, they are the same person, but represented slightly differently. So, how do we reconcile all those entities into one entity? And how do we clean up the knowledge graph? There may be implicit links which do not show up in your text, but that you can infer as relations by using existing structure in your graph. So the example I give is a family relation, right? You might extract that I am the son of X and I am the brother of Y, but that Y is the daughter of X may not show up in the text, but it's common sense, right? And it's not a half sister or that kind of situation. The point is that it's full siblings and parents and so on. That is like you can infer that from the semantics in the graph, right? So that is what we call knowledge graph completion. And that is another section, and that tends to use graph theoretic techniques and knowledge graph embeddings and probabilistic programming and so on. And then, we also have chapters on how to access the knowledge graph. So how do you query the knowledge graph? What are the querying languages and infrastructure where you store the knowledge graph, like Neo4j and so on? What are the applications and ecosystems? Knowledge graphs in science, knowledge graphs in industry. We have chapters on all of that, and also how you represent knowledge graphs, because there's a lot of formalism around how do you represent the knowledge graph in a rigorous way so that you can then query it. So all of that is in the book. So this is a very comprehensive book. It's almost 600 pages. Some chapters are more advanced than others. So it's a textbook, basically, that sort of tries to take you from beginning to end on what knowledge graphs are, what are the fundamentals, what are the techniques. So how do you build these knowledge graphs? How do you clean these knowledge graphs? How do you access these knowledge graphs? So there are sections on all of those as I described. And also, finally, what are the applications? So where are these knowledge graphs getting used, and also what the future is moving forward? So that's kind of where the book goes. And the reason why we wrote the book is because we signed the contract with MIT Press in 2017. I had joined the USC in 2016. At the time, knowledge graphs was still not a very popular term. The Google Knowledge Graph had come out in 2011, but at the time, everyone thought that this is a very one-off or, it's kind of a specific technology that Google has come out with. It wasn't clear that the term would take off and everyone would start using it. But over the last 10 years, the term has become standard. And we have conferences on it, and there are papers and applications all over the place. Sometimes, they don't call it a knowledge graph, like Amazon product graph has chosen not to call it a knowledge graph. But in essence, it is very similar to a knowledge graph. And so the term has taken off. The academic literature has really matured. There are hundreds of papers over the decades. And so we felt that the time was right to actually put together a textbook. There was no textbook on this. And, we just felt that the time was right, and that by the time the textbook came out, there would be a real need for it. And I think that this is a very good time for the book to be coming out. And, we are very excited to see what the reaction will be and whether people find it useful or not.
Very exciting, absolutely. Well, if someone is new to the space but excited about it, maybe they even have a use case in mind, how much theory do they need before they can start getting their hands dirty with some code and analysis?
So in every chapter in the book, one of the things that we do is we have a software and resources section at the end of every single chapter. I do not believe there is even one exception. There are 17 chapters in total, and at the end of every chapter, we provide a software and resources where we tell you what some of the code packages are that you can use. Now, obviously, we cannot give a tutorial on all of those. But the nice thing about the way that the open source tools and software has evolved is that many of them are very well documented, and it's not difficult to go and do the tutorial and figure out how to use them. So the book in some sense gives you the conceptual background with very real examples so that you kind of understand how the tool is placed contextually within the space that we cover. And we kind of tell you these are the main tools, and if you want to build a graph, then you should use this. If you want to think about it from an NLP standpoint and you want to extract information, here's the toolkit that you might want to use. And the truth is that if you're trying to build a knowledge graph from scratch in a given domain, will still require some expertise because it's a relatively advanced topic. It's kind of like reinforcement learning or deep learning. It's still not very easy to do. I mean, the tools are out there, but it still requires some expertise in order to do really advanced stuff with it. But the nice thing is that everyone can pick up the tool and read the book from beginning to end. We've tried to make it self-complete, starting all the way from the beginning. So you can read it from beginning to end. Some chapters will be harder than others, but in all the chapters, there are exercises, there's a software and resources for the more academic researcher who wants to learn more about the topic, even non-academic. We also have a bibliographic notes. So we try not to write the book in a way that it becomes very dense. So we don't put citations in the chapter itself. What we do is that we write the chapter, we explain everything. Then at the end, there's a bibliographic notes at the end of every chapter. And that tells you all the other papers, the primary material that we drew upon, because most of it is other people's work, right? It's kind of a field. We are trying to describe the field as a whole. Majority of the work is not ours. It's other people who have really done the work over many hundreds of authors and papers. And we are just trying to summarize and organize it in our own words. But we try to give the bibliographic note that these were our primary sources. And if you want to learn more about this specific topic, here's the survey that you need to go and read. Or this is a seminal paper on this. This was the first paper that was published. So if you go and read that, you'll kind of understand where they were coming from when they wrote that paper, whether it was 10 years ago or even 40 years ago in some cases. We've given credit to everyone that has contributed in any way to our primary understanding. And that is, one resource, and the software and resource is another resource. And then the exercises is yet another resource. So, then the chapter itself provides a conceptual backing. Hopefully with all of that, it will be maybe not completely easy, but we would hope easy enough that someone who is serious about it and wants to invest time into it can really go all the way with this.
Well, there's too much covered in the book for us to go into everything. So maybe for the last leg of our conversation, we could zoom in on one chapter area. If you have a preference, we could certainly go in that direction. But one of the things that caught my attention was your mention of knowledge graph embeddings. I know a lot about embeddings in natural language processing. What's a knowledge graph embedding?
So a knowledge graph embedding is basically an algorithm, or it's a machine learning algorithm that will take a knowledge graph as input. And this is usually an incomplete knowledge graph. And that's the point of getting the embeddings, as I'll explain in a moment. But imagine that you're taking an incomplete, there could even be some noise into it, a knowledge graph as input. When the algorithm is done, at the end of it, it will give you a vector that for each entity and also for each relation in the knowledge graph. So just like the natural language embedding, where, in the traditional word embeddings, you would have an embedding for each word, and then you can try to, construct sentence embeddings from that and so on. The more recent natural language embeddings are much more advanced, where they will give you a different embedding for a word, depending on the sentence that you provide as context. But the premise is that, the units are converted into a vector. And then once you're in vector space, then you can do all kinds of cool things like cluster the vectors together or figure out when there's a relation between, let's say, two entities, right, which are now represented as vectors, and so on and so forth. So in essence, we are converting each entity and each relation to a vector. The vector is usually very dense. It is real valued and dense. It may be, 50 dimensions, 100 dimensions, again, very similar to natural language embeddings, even 10 dimensions. Once you embed the initial knowledge graph, then the idea is that you can discover new relations, or you can figure out which triples are incorrect. There are relations or facts in the knowledge graph that are incorrect. Then the embeddings can also help you to figure that out. So that builds on the embeddings. That is not directly the embeddings, but once you get the embeddings, you can do those other things. So just to give an example, you can construct, like if you have a head entity, let's say Rome is the capital of Italy. Now, I don't know if it is the capital of Italy. I believe it is, because I always get confused with Rome or Milan, but I think it's Rome. So if Rome is the capital of Italy, but instead in my knowledge graph, I see that Milan is the capital of Italy by accident. If the embedding is good, it may actually be able to tell you that the probability that Milan is the capital of Italy is lower than the probability that Rome is the capital of Italy, assuming that I got that right to begin with. But, that kind of thing. And so you might wonder, well, how does it know that? How does it do that? And the reason it knows that is because there's a lot of connectedness in the knowledge graph, right? So it's able to learn by looking at what the other capitals are and how they are connected to the state and to the economy and so on. It can infer that this is the capital of this country or not. And maybe an easier way to state it is if you have a social network, right? And then you're trying to figure out, are these two people friends? I mean, that might be an easier example to think about. You can kind of think about, okay, if the two of us are friends, then chances are we may have common interests, we may have common friends. If you have a signed network where I know not only who your friends are, but who is blocking you, right? Which Twitter and some of these internally many social networks do know that. So that's like a negative sign. It's a signed network. Then I can also use another rule, which is that if we have enemies or there are too many people who are in my friend circle who are blocking you, then chances are that you and I are not friends. The nice thing about knowledge graph embeddings is that it looks at the whole graph and it kind of tries to learn the vector that captures all of that. You don't have to give it the domain information directly. So you just give it the graph and it just learns the vectors, and it seems a little bit like magic. Sometimes it is a little bit like magic because maybe that it doesn't perform well if your graph is extremely noisy or extremely sparse, and it won't be able to learn the embedding properly. But assuming that your graph is not too bad and it's big, right? So all these embeddings rely on a huge amount of data. So you do need a knowledge graph that at least has tens of thousands of entities, if not millions of entities. And so at that scale, when you have a lot of entities and relations and they're all connected directly or indirectly, then the machine learning, the deep neural networks that learn the embedding are just able to use all of that when they are optimizing. And then the idea is that they can give you new information about the entity. So it kind of falls into knowledge graph completion for obvious reasons. You can't use it to construct the knowledge graph usually from the natural language, but once you construct it, then you can use it to clean up the knowledge graph or to do more with the knowledge graph. So the knowledge graph embeddings falls within the knowledge graph completion / knowledge graph identification phase of knowledge graphs.
So I assume the book goes through some of the details as well. Tell me a little bit about the code I might get in that chapter. What does a reader will I end up playing with after I learn these skills?
So I remember that in that chapter, one of the code bases that we point to, and it should still be online, I think it's called OpenKE, if I'm not mistaken. And so, the OpenKE has pre-trained knowledge graph embeddings for Wikidata and DBpedia and, several other sources. So it already pre-trained those embeddings, similar to Wikipedia word embeddings and so on. And it also gives you, software for training your own embedding. So, we've used OpenKE and, it's one of the packages that works very well. There are some other packages that also work well, but that's the one that comes to mind. And we kind of point that out in the software and resources that here's a package that, if you want to train your own embedding or you want to use pre-trained embeddings, this would be the best resource. And in some cases, some embeddings are, have been published in the academic literature, but the software for them is not mature or the software has not been released. So in those cases, if you really want to use those, you would have to code the objective function in using TensorFlow or PyTorch, and then you would have to train the embedding. And, that's where some expertise would come in. So it really depends on which which embedding you're choosing. What we have discovered is that there are a small set of embeddings that tend to work very well in practice. These were some of the early embeddings that were proposed in 2013 or 2014, so not a long time ago. But even though there have been many algorithms that were proposed after that, these initial, the ones, Crancy is one such algorithm that was proposed in, I believe, 2013 or 14, tends to work very well. It's very fast, it's robust, everyone uses it or compares against it. And the OpenKE implements that and also gives you pre-trained Crancy embeddings for some of these data sets. And so it really depends on what you want to use it for. If you want to train your own embedding on your knowledge graph, then you would want to use the software. If you just want the knowledge graph embedding from a common data source and you don't want to train your own embedding, then you would use the pre-trained embedding that they have released.
Well, it's great to have those available. I can't imagine training my own, but using some sort of transfer approach could be very fruitful.
Yeah, and we really have to thank all the researchers who have, made these available. I think it's not completely altruistic because I think that they get rewards also from doing that. Because when you see that people use it, they cite it, they are able to, really do a lot with it. But I think that, we were very encouraged to learn that for most of the chapters, not all, but for most of the chapters, we were able to find good packages that are out there. And it's just a simple matter of knowing about them. Once you know that they exist and this is the name of the package, then, going there and doing the tutorial or, downloading the pre-trained model in some cases is really not difficult. But it's more difficult to know that, okay, this package exists and it's out there and this is the one I want to use for this purpose. I think that the book, kind of provides almost metadata on saying that, if you want to do this, then these are the things that you may want to look at. They all have different pros and cons. But if here are the available packages to our knowledge. This field is moving fast, so there may be some packages that we were not able to put in there, but that have since been released. But overall, we have chosen to go for very established packages. So the things that are in there that we have cited in Software and Resources are established packages. They have been around, they have stood the test of time. Many people use them. I think that you want to start with them. And then once you master those, then there are probably more cutting edge or experimental tools that could be used, but those are the ones that are established. And we try to err on the side of more established packages in the book because we just feel they have a record behind them.
Well, as you said, the field's evolving pretty quickly. Perhaps to wind up, do you have any advice for any ambitious researchers on where they could make some high-impact discoveries?
I would say there are some domains where there's a great chance for impact. So, for example, in the financial domain, we have become interested in that. I know there are other people who have also become interested in that. There are companies that I understand are very interested in that. So I think the financial domain is a good one because a lot of financial data is becoming available, open corporates and so on. So if someone has an interest in that, then that would be one. Another one is, something like healthcare, for example, right? Where again, if you have some knowledge in that, if you have some expertise in that, it's not that the data is completely opaque. There are some very good health data sets that are out there. And so, that could be another domain. Also, it's just part of it is also collecting your own data. So we have a chapter on what we call domain discovery, which means that when you have a domain, can you crawl the web? Not the whole web, but the portions of the web that are relevant to your domain. And this falls in the field of focused crawling and that line of work, which has been around for a while now, but I think is very important, has sort of slipped away from the academic community because it was very popular in the 2000s more than any other period. But I think everything is on the web. I think huge chunks of data are on the web. E-commerce is another big one, although you will probably have to collaborate with someone on that because I don't think it's too open. So we've had collaborators in e-commerce, so we tend to work in that. So I think that the bigger question is what is the domain where the individual who wants to work with knowledge graphs, hopefully they have some domain expertise already, whether it's cybersecurity or finance or healthcare or legal domain is another big one, e-commerce, manufacturing, politics. There are many, many good domains out there. If you know about knowledge graphs and you know how to build and use the knowledge graphs, then when you combine that with your domain knowledge, you can build a very powerful application. So I think both have to come together. And so it's very important that the person who is using this or is trying to use this, whether as part of a team or a company or just individually, should ask themselves, well, what is the thing that I know a lot about? And then the knowledge graph sort of allows you to give that knowledge to the machine so that then the machine can try to do a lot with it. But if you yourself don't know a lot about it, then I think that you're kind of fishing in the dark, because you can still construct the knowledge graph and do all of that, but how will you validate it and what do you use it for? And how do you know that it's doing something interesting if you yourself don't have the domain knowledge to assess that? I think that the people who are finding the best use cases and who are also finding the most success are the ones who already have some domain knowledge or are working with someone who has domain knowledge, and then the knowledge graph becomes a very powerful tool that they can use to have greater human AI collaboration in a way by using the knowledge graph.
Well, Mayank, where can people follow you online?
I think LinkedIn is probably the best way to follow me. So I'm on Twitter also, and you can follow me on Twitter. But personally, I am much more active on LinkedIn. So, if you would like to have a dialogue, I am more than happy to engage with that. I usually love talking to people who work in startups, who work in industry. Often they will just ask me, hey, can you consult with us? And I'm like, right now I'm not looking for an extra gig necessarily, but if you want me to come and give a talk or have an informal conversation with people inside your company, I'm more than happy to do that. I no charge in a way, because I just enjoy talking to people and seeing what their problems are going forward. And so I'm really looking forward to very good opportunities down the line for collaboration. People who want to really use knowledge graphs, want to use networks, and are looking to solve an interesting problem. Those are the people I would love to connect with. All the best ideas come from there.
Well, Mayank, thanks again so much for coming on the show. I'm going to remind people the book is Knowledge Graphs, Fundamentals, Techniques, and Applications. We'll have links to that and the social media stuff we talked about in the show notes. That's it for today, everybody. If we're not already connected, find a way to connect. Data Skeptic is on Twitter, Facebook, all types of places. And if this season gets picked up, maybe we'll focus a little bit on more Rosetta component of the show. Anyways, catch you next week.